Hi everyone, this video is on multiplying binomials. But before we do that, let's just do a quick refresher on how to expand and simplify. So if I have this example right here, I would make sure to distribute that 3x squared to everybody. So when I multiply 3x squared to 4x squared, I'd get 12x to the power of 4. Remember, when you multiply, you add exponents. When I multiply 3x squared to minus 2x squared, I would get 6x to the power of 4. And we end up getting like terms because these are like terms. And then I'd multiply 3x squared by the 6x, and I would get 18x to the power of 3. Next, be careful. The only thing that's getting distributed through here is this negative sign right here. So when I distribute this negative through to x to the power of 5, I get negative x to the power of 5. When I distribute it through here, I get negative 5x to the power of 4. And then here I get positive 4x to the power of 3. And then I can just copy down this 7x to the power of 5. Okay, beautiful. Now I just need to collect my like terms. And I'm going to put it in descending order all at the same time. So the highest exponent I see here is 7x to the power of 5. And then there's a minus x to the power of 5 here. So that gives me 6x to the power of 5 because 7 minus 1 is 6. Then I have 12x to the power of 4 minus 6x to the power of 4, which is 6x to the power of 4, minus 5x to the power of 4 is 1x to the power of 4. I also have 18x cubed to collect with 4x cubed. And when I put those together, I would get 22x cubed. So this is just a refresher that's going to be helpful when we expand binomials. So remember, so just a heads up that a binomial means an expression with two terms. Just like a bicycle is something with two wheels, a binomial is an expression with two terms. So we can use the same concept to multiply a binomial by a binomial, still using the distributive property, and then simplify by collecting like terms. But when we do that, when multiplying a binomial by a binomial, you need to multiply each term in the first bracket by each term in the second bracket. So let's talk about how this would look. I have this first bracket here, and I'm going to multiply it by the second bracket that I have right here. But really what has to happen is I have to make sure that that 2x that I have here gets multiplied to everybody inside of here. So how would that look? I would write down 2x, and then I would make sure to multiply it by everybody inside of this bracket right here. But if I do that with a 2x, I also have to do that with the 6. So now I'm going to take the 6 and also multiply it by everybody inside of this bracket right here. And then let's go ahead and expand. So right here, 2x times 5x is 10x squared. 2x times 3 is 6x. 6 times 5x is 30x, and then 6 times 3 is 18, and then I can collect my like terms, which are the 6x and this 30x, and this would be my final answer. I've expanded it. One quick thing though that I want to let you know is that essentially what I did here is I took this 2x and I multiplied it by the 5x, and then I multiplied it by the 3. And then I took this 6 and I multiplied it by the 5x, and then I multiplied it by the 3. So you don't have to actually write it all out like this if you see it this way. And there's actually a mnemonic device that we can use to help us know how to do this expansion right here, but it only works for a binomial times a binomial. And that mnemonic device is something called FOIL. And FOIL is just a mnemonic device to help you see what we did here. So do you see how we took this 2x and multiplied it by the 5x? So this right here, this F stands for the first. We are multiplying the first term in this bracket by the first term in this bracket. So when I do that, I get 10x squared, okay? The O stands for the outer. So we multiply by the outer term on the first bracket by the outermost term on the second bracket, or outside. And when we multiply those together, we get 6x. Then the I is where we multiply the 6 by the 5x. These are the innermost terms. And then the L stands for last, where this is where we multiply the 6 by the 3. This is the last term in the first set of brackets. This is the last term in the second set of brackets. And then you multiply that together, you get 18. Then at the end, you just collect your like terms together and you end up getting 10x squared plus 36x plus 18. Either way, you get the same answer. Okay, and it doesn't have to be in this order. It doesn't have to be first, outside, inside, last. We just do it this way to kind of help you remember what to do. So those are two options of ways that you can do it. They're pretty much the same option. But it says here that we can also use an area model to expand a binomial multiplied by a binomial. So what is an area model? What does that look like? Well, for example, let's just do a quick example right here on the side. 2 times 3 is 6, but the reason why 2 times 3 is 6 is because 2 times 3 means you have one side of a rectangle that is 2. You have another side of a rectangle that's 3. So here's 2 times 3. You have 1, 2, 3, 4, 5, 6 square pieces. So that's the reason why 2 times 3 is 6. Well, what does that have to do with this? We can also use an area model to expand this binomial. This is 2 by 2, 2 terms by 2 terms. I can make an area model that is also 2 by 2. And when I do this right here, it's going to look as follows. And I would take the first binomial and I can put it either on the top or I can put it on the side. It really doesn't matter. So I'll put it on the top. And each term gets its own box. So since the first term is 3x, I put a 3x there. The second term is a 1, I put a 1 in the second box. Okay, and then the second binomial is 2x minus 7. Since I've already used the top part, I now have to use the side part. So right here, the first term is 2x, and then the last term is negative 7. Let's talk about what this is going to look like. So in this box right here, we have a length of 3x and a length of 2x. So to find the area of that box, you would multiply those together and you would get 6x squared. In this box right here, we have a length of 1 and then a width of 2x, or vice versa, right? So we multiply 1 by 2x, we get 2x. In this box over here, we have 3x by negative 7. So we multiply those together, we get negative 21x. And then in this box right here, we have 1 by negative 7. And 1 times negative 7 is negative 7. And then at the end, we just make sure to collect any like terms that we might have, which are 2x and negative 21x. And then we just put this in descending order. So we get 6x squared. Collect these two together, you get minus 19x. Minus 7. So here's another option that you have. We're giving you multiple options so you can choose whatever makes the most sense to you. Okay, so now in example number 3, we want to be extra careful about this question because quite often people will make this mistake right here and they'll square everything inside here and they'll say this is the answer, and it's actually not. This is completely inaccurate. So I actually want you to write this down right here, and then I want you to put a big X over it, and I want you to say, no, this is not correct. And I want to show you why this is not correct. You don't have to write this piece down, but I just want you to show why this is not correct. So let's say X equals 1. If X equals 1, I would plug that in for X into the bracket. And then I would get 5 times 1 is 5. 5 plus 11 is the next step. 5 plus 11 is 16. 16 squared is 256. But then let's plug in X equals 1 into this expression. So I would get 25 times 1 squared. And 25 times 1 is, or 1 squared is just 1. So 25 times 1 is 25. Plus 121 would give me 146. These are not equal to each other because they're not equivalent to each other because we are missing something super duper important here. So what is it that I'm missing? Remember, when you are squaring something, it means you are going to multiply it by itself. So this means that I'm going to take 5x plus 11, and I'm going to multiply that by 5x plus 11. And then for this example, I'll just use FOIL to figure this out. So remember, F stands for first. So 5x times 5x is 25x squared. O stands for outside, so I'm going to go to the outermost terms and multiply those together, and I get 55x. I stands for inside, so I'm going to go to the innermost terms, multiply those together. And then L stands for last, so I'm going to do 11 times 11, which is 121. Then I'm going to collect my terms together. And I know that these two together would equal 110x, and then I would add 121. So if you notice right here, this being the final answer, it's missing 110x, which is a huge amount right here. So let's double check to see if that matches with this 256 when x equals 1. So I will do 25 times 1 squared plus 110 times 1 plus 121. 25 times 1 squared is 25. 110 times 1 is 110 plus 121 right here. When I add all of these numbers together, so like 121 and 110 is 231, plus another 25 would give me 256, so it works. Now, I didn't necessarily prove that this works, but we know that it works because I did it algebraically. But by showing x equals 1 gives us two different answers here, we have for sure proven that this does not work. All right, in example number 4, it asks us to expand 2 times x minus 1 squared. And make sure that we are going to follow BEDMAS first. So we have to do our squaring first before we multiply by 2. So let's go ahead and figure out what this is going to look like. So I'm going to copy the 2 down, and then I'm going to square x minus 1. So I'm going to write down x minus 1 like this right here. And then after I do that, I'm going to copy the 2 down, and then I'm going to expand this right here. So I'm going to do x times x, which is x squared, x times negative 1, which is negative x, negative 1 times x, which is negative 1, and negative 1 times negative 1, which is positive 1. Now, I can either distribute next or collect like terms. It doesn't really matter. Either way will work. These together give me negative 2x. And then after that, I distribute the 2 through. So I get 2x squared minus 4x plus 1, plus 2. And then this would be my final answer. Now, one quick note that I would like to say is even though I said to do this first, once you expand, once you write out x minus 1 times x minus 1, now it turns into multiplication. And you can do this in any order. So if you want, you can distribute the 2 through first, but only distribute it to one set of brackets and then expand by foiling, or you could foil first and distribute the 2 first. Either way, you'll get the right answer, the same answer. Now, in this next example here, FOIL will not work because when you FOIL, you need a 2 by 2. And here we have a 2 by 3. So foiling is not going to work for this, but it's still the same idea. So I'm going to rewrite the example down, and I'm going to multiply. Normally, what we would do up here, like here, what we are doing here is we multiply the 5x here by the 5x and then the 11. Here, I'm going to do the same thing. I'm going to multiply the x through to the 2x squared, but I'm also going to multiply it to the 3x and to the negative 1. So I'm just going to multiply it through 3 times instead of 2 times. So x times 2x squared is 2x to the power of 3. X times 3x squared is 3x squared. X times negative 1 is negative x. Then I'm going to multiply negative 5 by 2x squared, so I get negative 10x squared. Negative 5 by 3x, so I get negative 15x, and then negative 5 by negative 1, and I get positive 5. Once I do that, I just have to collect my like terms. So nothing's like this 2x cubed. but I do have 3x squared and minus 10x squared. And when I put those together, I get minus 7x squared. I also have a minus x and a minus 15x. So when I put those together, I get minus 16x. And then I add the 5. All right, in our last example, it asks us to expand this, but this whole thing is being squared, which means that I have to write this out as follows. But if I write this out like this right here, then I need to make sure that I distribute the 3x squared to everybody, the 6x to everybody, the minus 2 to everybody. When I have so many terms like this, I actually prefer to use the area model. And again, you can use whatever method you like. You're given lots of options. I like the area model because when there's a lot of terms like this, it's really easy to get lost in all of these terms. And this helps me to make sure that I don't get lost. So because this is a 3 by 3, I'm going to write 3 by 3 in my box as well. I'm going to draw in 3 by 3 in my box. And this first bracket right here, I could put on the top or on the side. This time I'm going to put it on the side. Make sure that you put your signs there. The second bracket I'm going to put on the top. And then here, I'm just going to go ahead and distribute through, which is really essentially what we're doing anyways. So like here, I would do 3x squared by 3x squared, which is 9x to the power of 4. Here, this box right here would be 3x squared by 6x. So that would be 18x to the power of 3. And then this box right here would be 3x squared by negative 2, which is negative 6x squared. But notice here that if I were to distribute this 3x squared through, I would get this first row. So it's still the exact same thing. It just kind of helps me to visualize it and organize it better. It's pretty much a graphic organizer for us here. Then I would multiply this the 6x through to everybody right here, which is pretty much what I'm doing here. 6x is going to get multiplied by 3x squared right here. So when I multiply that, I end up getting 18x to the power of 3. Then it would be 6x by 6x, and double check this one because a common mistake people will make is that they will write down 36x when it's actually 36x squared. Here, this would be 6x by negative 2, and when I multiply those, I get negative 12x. And then in my last row right here, I would multiply negative 2 through to everybody. And that's pretty much what this is saying right here. So I would do negative 2 by 3x squared, and that would give me negative 6x squared. This would be negative 2 by 6x, which would be negative 12x. And then this would be negative 2 by negative 2, which is a positive 4. And then last thing I need to do is just collect all my like terms together. So 9x to the power of 4 has nothing like it. 18x to the power of 3 has an 18x to the power of 3. Negative 6x squared and negative 6x squared and 36x squared would give me, so negative 6 and negative 6 is negative 12. Negative 12 plus 36 is positive 24. Then I would have this minus 12x right here. And that would give me minus 24x. And then this 4 just kind of tags along. And this right here is my final answer. All right, that's it for this video. Let me know if you have any questions. Otherwise, we'll see you in class. Bye.